we put the laptop away, please? Today we're introducing our last quadrilateral. Okay, again, if the food's going to be a distraction during the lesson, it can go away. Put it away, please. Okay. The last shape we're introducing today is a kite.
What? A kite.
Is that actually what it's called?
Yes, that's actually what it's called. It's called a kite. Yes, the kites that fly are named after the shape, not the other way around. So, a kite is one in which there are two pairs of congruent sides, but they're consecutive. In other words, the congruent sides are next to one another. If they're across from one another on the quadrilateral, it's a parallelogram. If they're next to one another, it's a kite. A, B, C, D is a kite. If AB is congruent to AD and BC is congruent to DC. Now, if it has two pairs of congruent sides next to one another, that means it is not a parallelogram, meaning we cannot use any of the parallelogram properties for kites. Again, drawing your attention to the last page of your postulate sheet where it's got that little flow chart for you. Tells you what properties you can use. Kites, the only other properties you can use that apply to kites are quadrilateral properties. But kites have a lot of properties that work specifically with them. For example, the kite opposite angles theorem states that if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Specifically, it's the angles that are stuck between the non-congruent sides. In this shape, the sides that are not congruent would be like AB to BC. The angle between them is one of the congruent ones. Between the other pair of sides that are not congruent is angle D. That makes our congruent angle pair. Angle B is congruent to angle D. Now keep in mind that kites can be spun around. So it's not always going to be the top angle and the bottom angle. You specifically want to look for those congruent symbols. If it's pictured like this, where both congruents are on top and on bottom, then it's the ones left and right. In a kite, we also have the diagonal theorem, which says the diagonals are perpendicular. AC is perpendicular to BD. Now, what does perpendicular mean again? Nope. They cross at a specific angle. A right angle. They cross making a right angle. So, that means this right here is a right angle.
Really, all the sides are right angles too?
Technically, when they intersect, yes, all of these are right angles. Because if one of them is a right angle in the intersection, then all four of them have to be a right angle in the intersection. Also, in a quadrilateral, if you have the diagonals going through it, the kite diagonal corollary states that the non-congruent opposite angles were bisected by the diagonal. Okay. So this is going to be one of the ones that you're going to want to focus in on the picture more than anything.
It looks the same as everything else. Nothing.
When my diagonals go through the middle, diagonals go through all four angles of the kite. The two angles that were not congruent to one another. Which two were congruent? D and B. These two were the congruent ones. So I'm talking about A and C now, because those are the ones that were not congruent. They got bisected, meaning this little angle right here is congruent to the one below it. On the right side, same thing, but not the same as the one on the left. It's double congruency marks here, because they are not all the same. So the theorem itself technically says AC bisects angle BAD and angle BCD. But this is going to be one of the ones that I'm going to tell you to look at that picture to see what the congruencies are. The last theorem that's specific to kites says that if a quadrilateral is a kite, then the diagonal through the congruent opposite angles is bisected by the other diagonal. We established that B and D, those were the congruent angles. Now, technically, I gotta go more than the single letter name, but for the sake of ease, that angle and that angle were congruent. This diagonal goes through it. This diagonal got cut into two congruent parts. AC specifically bisected or bisects BD. What do we get out of this? BE is congruent to ED. This is congruent to this. And I have to use the triple segment mark because the single and double angle marks are already used by the sides of the kite. Now, I am going to emphasize this again. When it comes to your kites can be spun. Keep an eye on where the congruences are on the side, because if the congruences are not the left ones and the right ones, if it's the top two and bottom two, you need to spin this picture to see which diagonal pieces are congruent. So, much like we've been doing in this section, when it comes to these problems, what you're going to have to do is you're going to have to identify what shape it is, and then identify what things are labeled. Are the things that are labeled sides, angles, diagonals, parts of diagonals, or mid-segments? That's still going to be essentially the 5 different types of things that are labeled. First one I'm given is if the measure of angle QTS is 132 and the measure of angle RQT is 50 degrees, find the measure of angle RST. Okay, QTS. T is the pointy part, it goes towards Q, it goes towards S. That is the angle, a full angle of the kite. It's not one that got broken down into pieces. The next one it talked about was RQT. Q is the middle letter, goes towards R, goes towards T. It's another full corner. And we're looking at RST. S is in the middle, goes towards T, goes towards R. Every single one of those is a full angle within the shape. In other words, this diagonal is here to throw us off. If it's succeeding in throwing you off, draw yourself your own little shape to make it work. That's T, that's Q, that's R, that's S. QTS was 132 degrees. RQT was 50 degrees. Do you notice there's not a variable in the problem?
It's in those.
If there's not a variable, can I add an x to the thing I'm looking for? So RST is x. I'm going to put an x right here. So we're looking at angles of kites. There's a few things that we know about angles of kites. First off, there are some congruent angles. Secondly, we know that there's a right angle in the middle of the diagonals. We also know that some of the angles got cut in half by the diagonals. We just redrew our shape without the diagonals in it. So do you think I need either of these that work with diagonals? No, we're going to work with this one. We've got a couple of angles that are going to be congruent. The key thing is making sure we know which ones they are. To know which ones they are, keep an eye on where your congruent sides are. This side was congruent to this one, and this one was congruent to this one. The congruent angles are the ones that are between the non-congruent sides. Is angle R formed by congruent sides or non-congruent sides?
I thought the diagram shows the congruence different. For the congruent sides.
I don't understand what you mean.
It's on its side,
I legitimate don't understand what you mean. Can you explain?
Never mind. Is it just like a squish kite or something?
Oh yeah, yeah.
Oh.
They squished the kite. That's what you mean. Is that it just looks like it's taller this way instead of wider?
That's what yours confused me because I don't know.
Yeah, they just squished the kite, and they could do that. The key thing to look at is which ones are congruent. These two sides are congruent, meaning R is formed by congruent sides. I want the angles formed by the non-congruent sides, which means R is not included. Which two angles are formed by the non-congruent sides? Q and S. Q, that side's not congruent to that side, that angle. S, that side's not congruent to that side, so that angle. Those two are congruent. If they are congruent, that means they are equal. Do you notice that I have something marked on both of them? So I just set it equal. Well, that's an easy solve. X equals 50. Was I solving for x in the first place? No, I was solving for angle RST. But what did we call RST? X. So I just change it back. Measure of angle RST equals 50. Sometimes they might throw a little extra information in there. Like the 132, we didn't really need it. They throw it in there to make sure you're paying attention. Let's move on to question B. Are the things labeled with numbers specifically? Are they sides? Are they angles? Are they diagonals? Are they parts of diagonals? Or are they mid-segments? They are angles. Is this a kite? Yes, two congruent sides next to one another, two congruent sides next to one another. Angles of a kite. We had 3 theorems dealing with angles of a kite. First one said there's a pair of congruent angles across from one another. Second one said the perpendiculars create right angles. And the third one said one of the diagonals bisects the angles. Are the diagonals in my picture at all? No, which means these 2 theorems are not helpful. I'm using this theorem again. The key thing is knowing which angles are the congruent ones. which two angles are formed by the non-congruent sides? Nate, what are you thinking? F and H. F is stuck between a single and a double marked side, so is H. This angle's congruent to this one. Do you notice that neither of them are labeled with anything? Okay, so that becomes a bit of a challenge. Do you also notice that what I'm looking for is one of them? This angle. Third thing to look at. Do you see that there's not an X involved in the problem at all? So the thing I'm looking for, I can call X. It's GFJ, it's this one over here. I'm going to call that one X. Now I've got a label on one of them. So can I put the label on the other one? I can also call that X. Now earlier I talked about the fact that you can only use the properties of kites and quadrilaterals for kites. We used all the properties for kites that we knew about angles that applied to this picture. So now we need to use information about quadrilaterals. What do you know about quadrilaterals? First off, what makes it a quadrilateral? 4 sides. That's exactly what makes it a quadrilateral. It has 4 sides. Okay, so we need to think about what we know about the angles of a quadrilateral. Well, a quadrilateral is a polygon. Quadrilateral has 4 sides. Its interior angles add up to 360. How do we know that? Technically, using this formula from forever ago. 180 times 4 minus 2 gives us 360. Do you recognize that in this picture, all 4 of my interior angles are marked with something? And we have a theorem that says the interior angles of a polygon is 180 times n minus 2, which for a quadrilateral is 360. This is what we're going to use, and we're going to use it a decent chunk with kites. If you have all 4 angles of a kite labeled, then all 4 of them will add up to 360 because of that 180 times n minus 2 piece. 128 plus x plus 72 plus x equals 360. How do I solve that? Combine like terms. X plus x is 2x. 128 plus 72 is? Y'all got calculators, right? If not, grab one. 200. Subtract the 200. I get 160. I divide by 2. Just 80. Is x what we were supposed to be solving for? We were supposed to be looking for the measure of angle GFJ. But we called GFJ x, therefore the measure of angle GFJ is real simple. It is just the 80. Sorry, I got distracted by a different problem. Okay, moving on. Question C. It is a kite. It has got angles labeled. Do you notice that the angles have nothing to do with diagonals because there's no diagonals in the picture? Which means the only thing we know specific to kites is there is a pair of congruent angles. Can you put the laptop back away, please? Which angles are the congruent ones? If need be, line up your pictures. Line up your congruencies in your pictures. On this picture, it is the left ones and the right ones that are congruent. The left sides and the right sides. And in that, I'm going to write on my postulate sheet to make my life easier. These ones were the ones marked as congruent. Is this kite orientated the same way as this one regards to the congruencies? These two are congruent. These two are congruent. Those two and those two. It's regarded the same way. If it was facing more like this one, I could spin it. Congruent, 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 congruent. Or if you prefer to match it where it's single and double congruence, you can. You don't have to. Either way, that's why these two are the congruent ones. When I line up this one, it lines up this way, which means my congruent ones are P and R. Angle R is 66 degrees. Angle P is, as a result, 66 degrees. I'm supposed to find X. Did that actually like?
That was my phone. I have it on set up because my dad took me about it.
That didn't directly help us find X. Okay, let's turn it off, please. That didn't specifically help us find X, but do you notice that all four angles of the kite now have something labeled in them? What do the four angles of a quadrilateral always add up to? According to what we just wrote down earlier, 360. The 66 plus the 115 plus the 66 plus the X plus 15 will all add up to 360. It's used a lot with kites. I combine my like terms. I've just got a single X. Ooh, 66 plus 115 plus 66 plus 15. 252
262.
day. 262. Oh yeah, that makes more sense. And I subtract 262. 360 minus 262 is 98. Is X what we were solving for?
Yeah.
Yes. Question D. Find the measure of angle MNL.
90.
Why is it 90?
Because all the four inner ones are 90.
These four inner ones are 90, and MNL has N as a vertex, goes towards M, goes towards L. It's this angle right here. It's a 90-degree angle. Some of them are going to be that simple. Some of them might be a little more complex. We got 2 more left, and then we've just got a page that we're talking about a little bit. Okay. Given the measure of angle QTS is 148 degrees, find the measure of angle PST. QTS. T is the vertex, goes towards Q, goes towards S. It's this big angle here. I can't really write it in the picture because the diagonal's going through the middle of it. Angle PST. S is in the middle, goes towards P, goes towards T. That one is what I'm looking for. It's right here. I notice there's not an X in the problem, so for the sake of ease, I'm going to call that X. It's angles again. This time around, I have a partial one of the angles. It's not a full angle of the kite, which means doing the adding to 360 thing is probably not going to help me here. I have to use something else. I have to use the angles involved with the diagonals. With the diagonals. Angles I know. I know these middle 4 ones are all 90. So I'm going to put a right angle in there. And I'm going to put it in the closest to the one I'm looking for. I could put it in all 4 places, but for the sake of ease, I'm not going to. The other thing we know is the bisecting with the diagonals. That's our third one. Some of the angles got cut in half. We just got to check which ones they are. Here's where having your notes, lining the picture up, having your postulate sheet filled out could help you. I know we don't have it yet. I just put the markings on my thing. If I line my kites up this way, are the congruents lined up in the right spots? No. On this one, the congruents are on top and on bottom. So I spin it. Is it now lined up correctly? Which means this angle is congruent to this angle, and this one is congruent to this one. Do you notice that we've got a triangle here where there's something marked in every corner? I'm hoping that's going to help me. The only thing is, okay, I'm looking for this. This is 90. Do I know the measure of this one? Cam, you're shaking your head yes. What do we know?
Measure of it.
What is it?
148.
Not
Mine
quite.
is like half.
In half. The full thing's 148. And if those 2 parts of it are the same, then the 2 parts are half of it. It's 74 degrees. It's half of this. So now I've got a 74 degree angle there. Essentially, I've got a triangle going on, and I'm going to redraw just because I can't really see it on here anymore. I got a right angle, I got an X, and I get a 74. What do you know about the angles of triangles? They add up to 180. X plus the 74. Don't forget to add the 90 equals 180. So, much like with rhombi, you can use triangles to help us out here as well. And I get x equal to 16. Okay, we got one more problem. And then we got that last page to talk about a little bit. We talked about a lot of it already, actually. Question F says solve for x given that nk is x plus 6, ln is 3x minus 7, nm is 16, and jn is 8. nk goes from here to here. X plus 6. ln goes from here to here. 3x minus 7. nm goes from here to here is 16. And jn goes from here to here is 8. Which are congruent? So this is bringing us back, because these are diagonal parts, and in a kite, what do we know about diagonal parts? Is there is a pair of congruent diagonal parts. We have to make sure that we've got the correct ones. If I line my shape up this way, are my congruences in the right spot? No. I want 2 on top, 2 on bottom, so I'm going to spin. And once I've spun it, 2 on top, 2 on bottom, these 2 diagonals are the congruent ones. So yes, Nate, you're 100% right. The 8 is congruent to the 3x minus 7. And congruent is just a fancy way of saying things are equal. Three x minus 7 is equal to 8. Add 7, 3x is 15. Divide by 3 and x is 5. So, big thing on the kites is making sure you're using the right pieces, lining that kite up correctly. The last page of our notes technically is talking about something we already know. We've already been talking about it. I've drawn your attention to that diagram on your postulate sheet already. Last page of our notes really just focuses in on the fact that these quadrilaterals that we've been dealing with for the second half of the chapter tend to deal with other things as well. And so when it comes to a shape's property, properties that apply to that shape will work with any of the properties directly above them in this flowchart. And I've worked with you on that already. So it's just a reminder of that fact. Otherwise, we've done all that already. Today we did 7.5 day 2. Today is the 22nd. Our homework's due on Tuesday. What's happening Tuesday?
Test.
End of the trimester.
All of those things are true. It's your chapter 7 test, which is your final test. It's the end of the trimester. It's the last day to turn in the homework for the unit.
And it's the last day of the week for the school.
And it is the last day of the week.